Hi, everyone. Thank you for coming. I hope you had a really great Saturday so far. This is Dr. Wei Sun, who's the co-founder and CEO of AIWaysion. AIWaysion leverages technologies such as artificial intelligence, which is AI, and edge computing for safer and more efficient transportation. So, Dr. Wei Sun, whenever you're ready, please go ahead with your presentation.
Cool. Thank you, Julia. It's good to see you.
Thank you.
Yeah. So basically, maybe I'll just give a quick introduction about myself and also AIWaysion. And also, first of all, thank you for the opportunity to invite me to give this talk. And my name is Wei Sun, and also have actually a long history background in academia. I have Ph.D. in transportation engineering. Actually, prior to co-founding this company, AIWaysion, I actually worked as a postdoc research associate for 3 years in University of Washington. And then we have this tech transfer process, and actually we found this company. Some of the technologies I'm going to talk about today is actually developed at the University of Washington. So without further ado, let's go into the presentation. Yeah, maybe the video first.
Traffic collisions are one of the leading causes of death. Unfortunately, there's an estimate of 5 million crashes in the US every year. To improve traffic safety, the University of Washington STAR Lab has developed a connected vehicle device, the Mobile Unit for Sensing Traffic, or MUST. MUST is a comprehensive sensor fusion and edge computing device that can be used for multimodal traffic sensing, roadway conditions monitoring, smart parking, and connected vehicle applications. Multiple sensors, including a video camera, Bluetooth Wi-Fi detector, and temperature and humidity sensors, are integrated together to address the diverse needs of smart transportation. Taking advantage of edge AI technology, MUST can produce volume and speed data of road users, road surface conditions, and travel time estimates. In addition, MUST can be configured as a communication unit on the infrastructure side for connected vehicles and other smart transportation applications. MUST has been deployed in Seattle, Bellevue, and Linwood in Washington State, and the E8 corridor in Norway for applications including traffic and roadway conditions monitoring, hazard event detection and warning, vehicle localization to support autonomous driving, and curb space management. PacTrans and the University of Washington Commotion have funded product development and commercialization of MUST. MUST and its related IP have been exclusively licensed by AIWaysion, which is a University of Washington spin-off company providing smart mobility solutions using AI and edge computing technologies for safer and more efficient transportation. If you're interested in knowing more, please feel free to contact us.
Yeah, just to make sure, is the video okay?
Yeah, we could.
Seems
we
like
could
there's
do things
little
up first. So
okay.
yeah, but it's good now.
Oh, okay, cool. Looks like there's some lagging on my screen.
Oh, okay.
Okay, cool. Yeah, so basically that's a video. I like to play that to before I give the presentation. Normally, this is actually a video we made right after we have this UW spin-off company, and right after we complete the entire procedure to transfer this technology to an entity. And this, as it mentioned in the video, basically this is a product developed at the University of Washington STAR Lab, and we are a UW spin-off company. We are still located near UW campus. We are, as you can see here, we have office in the building called Co-Motion Star Lab, Startup Hall. And you actually, if you're interested, you can find us there. So just another, actually a good news for us. We are just coming back from TRB. This is a Transportation Research Board annual meeting. Every year in Washington, D.C., we have this huge conference, especially in transportation engineering. Researchers, agencies, and also the companies from around the world, not just US, will attend this conference. And this is actually the first year that I come to this conference as both a speaker and also exhibitor. You can see here we have our booth there, AIWaysion. My colleagues there are actually showcasing the technologies I'm going to talk about today to the agencies and also researchers there. Some of the technologies actually I will be going into some details. It's actually real-time detection for anything related to traffic or even the roadway that you are traveling on. This is what we're showcasing right now. On the left side is actually live detection of pedestrian and also tracking as well as counting. On the right side is actually our star right now is actually Juliana from Yakima Nation.
Yeah, I love Juliana.
Yeah, yeah, you know her. So basically, yeah, Yakima Nation is one of the largest tribe in Washington State, and we just installed one device in Toppenish, Yakima Nation, and also we work with Juliana for a long time. It's good that she's there in person to support us, both the exhibition booths and also talk to a lot of people. Yeah. And also, I have given a speech, a similar speech like today as well at the TRB conference. But it's a good thing today I have a little bit more time so I can go into details of the slides. For the TRB, I only got like 20 minutes.
Okay, great.
Yeah. So some of the technology I'm going to go over today is the core of our products, actually this mobile unit for sensing traffic. It's called MUST. So similar to the title that I gave for this presentation is the IoT technologies for comprehensive sensing and the connected vehicle applications. So the IoT part basically is this MUST device. We have developed this device and actually implemented in several locations in Washington State. Most of the products are funded by US DOT or state agencies, WashDOT as well, and actually supported by some of the local states like City of Bellevue, City of Linwood, and also recently Toppenish in Yakima Nation. So the particular device, you can think of as a roadside unit with Edge AI capabilities. Basically, the AI algorithm can be implemented and also running on the device itself without the need for the support from the cloud. A lot of functions I will be showcasing later, but normally you have this device you install on the roadside, typically on a pole, high enough to monitor a certain section of the roadway and or entire intersection. Yeah, we also have software mostly for device management or data visualization or some more complicated control functions as well. These are actually for agencies to use when after they install our devices, they want to manage. And also for road users like travelers, some of the information we collected from this device can actually support the daily commute for the travelers in the community where we install the devices. Like we can provide messages such as warning messages about road surface conditions. If you are traveling near that location, it will be good you can receive such information for your trip.
Yeah.
So basically, this is some details about this MUST unit. You can think of it as a unit with perception and also computing as well as communication functions. We want it to be a device that the agencies can easily install and actually can even for within one unit you can accomplish a lot of things, rather than just as a sensor you can only sense a few stuff but with no other control or communication functions, which is most of the traditional transportation devices. So we're lucky that we are familiar and also we are exposed to a lot of innovative technologies like AI and also IoT. We combine those technology into this one unit, and mostly for transportation related purposes. For example, some of the use cases include like traffic, roadway, and the environmental conditions detection. As I mentioned, also dangerous events, hazard events detection and warning. And our unique advantage comparing to a lot of other stuff you might see before is the edge computing part, and also this in-device analysis. So basically, by doing that, we can actually reduce, reduce the amount of data that need to be transferred to, let's see, a cloud or a server. And doing that actually does not require broadband connection, the high speed, high bandwidth internet. This is actually especially good for conditions like in the rural areas, where there are actually no or a limited internet connection. We can actually do all those compute in local, basically meaning in this device, and also just send out messages like warning message or some of the critical information in text message to a mobile app or to the control device for some communication. And also doing this, it also protects the privacy of the community where you install this device. It is also a plug and play solution. Actually, it's easier to see on this slides that this is normally how you install our device. As I mentioned, we already installed many of those devices across Washington State, mostly funded by some grants funded by DOT. Normally, you just need to provide us the power on the pole. As I mentioned, for the communication, because we don't actually have to transfer any raw data or video or image to the server for further analysis. That's the reason why this whole device, the data communication can be supported by something like a SIM card via cellular communication. Let's see. Oh, yeah. So this is actually a dashboard system. We have both a web version and also a mobile app version. Some of the core information collected by the device, normally on the roadside, you can see here on the dashboard things such as temperature, humidity, road surface condition, whether it's wet, snow, icy, or some of the traffic information like traffic counts, traffic flow by direction, and also traffic average traffic speed, all those kind of information we can collect through our device. And also we can send out images in real time as well for validation or for monitoring purposes.
Okay.
Cool. Another part of the device, as I mentioned, is not just a sensor. We also wanted to be able to communicate not only to the agencies, or also to the users as well. Another huge part is actually for it to communicate with traffic control devices in real time and automatically. Yeah, so traffic control devices meaning something like a traffic signal controller that actually control the traffic signals that you normally see on the intersections, and also some of the variable message signs, those LED signs that can change message accordingly with some information feed. So through our MUS device, we can actually communicate with the traffic signal controller in real time with their API, and also the variable message sign as well. We can detect things like a road surface condition. If it's snow, we can send out messages to the variable message signs, basically ask people to proceed with cautious because of snow. Yeah.
Okay.
So those are some of the core functions of a mass device and the entire system, including the dashboard. One important thing when you talk about transportation application is actually latency. That's actually why we are working on this kind of device on the edge side, basically using the IoT technology to mostly to reduce latency. If you need to transfer video data or image data that's to the cloud for analysis, normally that would increase the latency. So there are some standards actually for those intelligence transportation system ITS use case for the latency requirements. Normally, for safety related applications, you need it to be under 100 milliseconds. For that include analysis, compute, as well as communication. So with everything on the edge, it's actually easy to be accomplished for those ultra low latency communication analysis. So these are actually some of the core functions of the comprehensive sensing as well as the connected vehicle applications. I will not go into details for each one of them. So I just give you a feeling of how those IoT technology can be applied to transportation engineering. I know you guys are familiar with robotics, but basically
Yeah.
maybe this can pique your interest in transportation as well.
Yeah.
Yeah. So for we on the left side we have some basic traffic sensing stuff like traffic, vehicle volume, speed, and also classification and travel time estimation, and as well also as we have functions like detection of the pedestrian, cyclists, or even people on scooters. Um, Another part is actually the condition where you are driving or walking or riding. Basically, you need to be aware of the road surface conditions, snow, icy, or wet, or environmental condition, temperature, humidity information, and also visibility information is critical to driving as well. Um, on the on the right side, basically, with the information we detected on the left side, we can apply some analysis and basically extract information such as related to safety or connected vehicle or parking, those kind of applications. Safety is a huge part for us because we want to use our technologies to reduce any severe injuries or fatalities.
Mhm.
Yeah, so we work with agencies. These are some of the most demanded functions for related to safety, like queue, congestion warning, stop vehicle detection warning, and also a live real-time detection of collision or near miss events as well. Some of the low visibility condition warning and also hazard dangerous road surface condition warning are also applied in our system. For connected vehicles, I'm not sure if the audiences are familiar with this term. It's basically meaning the vehicles are connected and can communicate with each other, and also the infrastructure and pedestrian, they are all connected and communicated with each other as well. So we this entire concept and also the current way of doing this is quite complicated. But we hopefully with our devices actually more um, easier for the agencies to implement. We have our own communication module, so we also have the detection functions. So with our device on the roadside, basically meaning on the infrastructure, we can provide those information dissemination communication with not only just vehicles but also to the pedestrians through cellular communication.
Mhm.
I would like to demonstrate some of the core functions through the project we have been working on in the past few years. So some of the project actually funded by DOT while we're still in University of Washington, and then there are a few that actually conducted by the company AIWaysion since last June. Yeah, so actually prior to June, I was still at University of Washington as postdoc, and then we have this a new company.
Nice.
So the first functions I would like to showcase as comprehensive traffic sensing. As you can see on the right side, basically we are able to detect the objects on the roadside on the roadway, normally by different types of objects, not just vehicles, but also like different types of vehicle, whether it's truck, van, bus, or agriculture vehicles as well. In the case of a recommendation, they are interested in those kind of a detection. So for another term we call the vulnerable road users, basically meaning the objects other than vehicles, like pedestrians, cyclists, scooters, people in wheelchair. Those are some of the objects we are able to detect. So detection is the first part for all the other more complicated applications. With accurate detection, we can do tracking for each object we can detect. And then through tracking, we can do the counting and also do speed estimation as well. We can also do a travel time estimation between two devices at the same corridor. We also can provide information such as temperature, humidity. Environmental sensors are one of the sensors we attach to our hardware device.
Nice.
Yeah. So for this particular project, the detection data collection is only the first step. This is a project actually funded by Washington State DOT. They have this organization called State Transportation Innovation Council. We partner with City Bellevue, City Linwood, install several devices at two corridors in both cities. And after data collection part, and also after evaluation of the accuracy of the results, we move to the next step, basically to detect some of the events that the City Bellevue, City Linwood are interested in for this particular corridor. Things like road surface condition, because both corridors in the cities actually have snow and icy conditions, especially during the winter season, and that can be very dangerous, yeah, to the people driving by. Especially these are some of the corridors that tend to have speeding events very frequently as well. So combining that, that's actually a very dangerous situation for vehicles drive at this location. So yeah, so basically we applied our devices there for like road surface condition detection, but also warning, and also queue warning, as well as speeding events detection warning, and some of the stop vehicle or those kind of events detection.
Okay.
Oh, I forgot to. Yeah, so that's actually showcasing some of the tracking, detection, tracking, and also counting of the vehicles.
So, how does the incident warning work? Could you explain a little bit more about that?
Yeah, so that's maybe a more broad concept. So
Okay. Oh.
so we work with the agencies. They decide what kind of events they are interested in. So incident normally meaning sometimes it's two vehicles have a collision. And
Oh.
sometimes it's just one vehicle by itself just for some reason just stopped there, or car broke down. So yeah,
All right, that makes sense. Thank you.
cool. Yeah, so this actually on the right side you can see the dashboard we developed for this project as well. Just showcasing actually showing one of the devices we installed in Linwood. You can see some of the core information collected on the roadside, like a temperature, humidity, and also road surface condition for the road segment that we are monitoring, and also the traffic flow by each direction. You can see the detection zone in the red and green, and also the showing the upstream and downstream traffic, and also the traffic speed as well. Some of the events information also collected and just sent to the agencies via text messages. Yeah. So another information in addition to traffic sensing, we also do road surface condition or those kind of environmental condition detection. Road surface is actually a very unique information that we're collecting because most of other traffic sensors do not do this. We also think this is actually very critical information that agencies are interested in because they have a high demand of such information. That's why we are awarded with this washed-out stake project.
Mm-hmm.
Yeah. So we develop our algorithm, machine learning algorithm, with information like the image processing with the images we collect on the road, as well as the temperature and the humidity information we collected through our environmental sensors as well. So using the watchdog, because watchdog they have the weather stations across the state, but not in large quantity because each weather station is quite expensive. So our solution is more cost effective because comparing to weather station, our solution is much cheaper, and we can provide more accurate and local information about the environment. So we actually use some of the locations like from the watchdog weather stations, collect their data as ground truth, and use that to train our algorithm for the detection. So comparing the ground truth, we're able to detect conditions like dry, snow, icy, and rainy conditions at a very high accuracy, I'll say. For conditions like snow and icy, we can achieve like over 90%, 90 or 95% accuracy as well.
Okay.
So visibility detection is another core function that we can provide with our device. So this is actually another project funded by WashDot. It's a project following the original one that I just showed you guys. So they actually are interested in using the same system to detect the visibility conditions of the roadway. So as you can see on the images on the left, those are some of the images we collected from our devices in Bellevue, Washington. So through our algorithm, we are able to quantify the level of visibility with image processing, and also again comparing the ground truth data we are able to collect through the weather stations by WashDot. So actually using a similar algorithm we have developed for visibility detection, we are able to do other things like improving our accuracy for detection of vehicles or pedestrians under adverse weather conditions, like heavy fog or rain. Those kind of weather conditions always cause like low visibility conditions. Under such conditions, normally it's actually very hard to detect or even actually see the vehicles or pedestrians with our own eyes. But applying our algorithm to the same image, as you can see on the right side, after applying those pre-processing algorithms, it's actually very easy to see, at least much easier to see those vehicles or pedestrians than these original conditions. So with that algorithm, we're able to improve our accuracy for detection. As I mentioned, it is a huge part for some other functions. Yeah, this is actually I believe, Julia, you are also familiar. This where we
Yeah.
install our devices in Toppenish, Yakima Nation, a few months ago. I think I actually have a video. So this is a location, actually, according to Juliana and her colleagues, it's the most dangerous location in Yakima Nation, because this is where the Highway 97 meets the local road, and particularly this because this is not a signalized intersection. It's actually just controlled by stop signs. So maybe I can play this one.
Okay.
Welcome back, everyone. Nearly 24 people have died on US 97 between Union Gap and Toppenish since 2001. Almost a third of those fatalities were at one intersection. But AIWaysion's Emily Goodell says WashDOT has installed some new technology they hope will help them make the intersection safer in the long run.
The stretch of U.S. Highway 97 from Union Gap to Toppenish has one of the highest collision rates in Washington state.
Where the highway meets side streets. And so you can't go over or under. And so if you're trying to cross a busy highway, you have to pause, wait for a gap, go really fast, and hope that you make it.
The spot where the highway meets LaRue Road in Toppenish is the deadliest intersection on the Yakima Reservation.
So there's been 7 fatalities at this intersection.
More than half died in a single collision in 2019.
The only person that survived was the gentleman in the freight truck. The 4 passengers in the sedan were all killed.
The goal is to figure out why these crashes are happening and how they can prevent any more from occurring so that no more family members have to put up a memorial like this one. They're doing that with a brand new year-long pilot project to put a new traffic camera called a MUST sensor at LaRue and 97.
The antennas here are what gives us the information.
Visibility issues, the weather, the kinds of cars going by, and how fast they're going.
It also can tell you road surface conditions.
It's hooked up to an app that can alert them to safety hazards.
So like if it becomes freezing conditions, we can let WashDOT know, they can put it on their reader boards, or if there's a crash, we can tell them the traffic is backing up on Highway 97 because the camera at LaRue and 97 identified a crash. We did get approved for the roundabout at this intersection. The funding's not there yet, so this will help us get the data that we need so that we can prove that we need the funding for this intersection.
And hopefully prevent any more fatalities at this spot. In Toppenish, Emily Goodell, AIWaysion Local News.
And state transportation officials say since they installed the first roundabout on that stretch of highway at McDonald Becker Road, there's been fewer crashes and no fatalities. Welcome.
Wow.
Cool. Yeah. So basically, we installed this one device, and as Juliana mentioned in the interview, we plan to actually install a lot more than this one device, but we are actively looking for funding for such projects. They actually have a list of intersections, about like 20 intersections that need similar monitoring and also control applications. So some of the control functions are listed here. So basically, we want this MUST device to be able to communicate with things like a traffic signal controller, as well as the variable message signs that you can see on the left side. So that way, actually, it's easier for the travelers at those locations to be able to see those information even before they arriving at this intersection. We are actually, as Juliana mentioned, basically there are a lot of crashes at those particular intersections. You can actually see the semi trucks at this particular intersection, and it's not just the Highway 97, but also on the side street, because that particular location there are a lot of agricultural vehicles, as well as the semi trucks, which is very dangerous because. Especially, actually, as you can see on this image, it's mostly covered by snow and without a typical signal head. So you have to be able to see conditions from both approaches before you approach. but most of the drivers there do not do so. So that's actually making it very dangerous. It's also very hard for the semi trucks to make a full stop
Oh yeah.
as conditions like icy or wet snow, even if they already saw there's a vehicle on these other directions. Yeah. So we're thinking we can actually, in addition to the devices for detection and also monitoring all those conditions, we're thinking to deploy all those message signs along with those critical roadways to actually send out alert messages in real time. We also have a dashboard mobile app, so the agencies can use to monitor the conditions in real time and don't have to go there to check, which is also very dangerous for them if they need to be there every day all the time to check the conditions.
Oh yeah.
So this is actually the plan for the next steps. We're working with AIWaysion. First, they actually want us to do more data collection. So because for this particular location, and also as a for the reasons I mentioned before, a lot of these rural areas, there are kind of basically no infrastructure support for a lot of advanced technologies to be able to operate at those conditions. Things as I mentioned, like broadband communication. Um, for traditional traffic sensors, normally you need to connect that to a cloud server to analyze the raw video data. But if we are doing that, basically at these locations, you're not able to transfer any video or image to a cloud because there are basically no internet connection. Even if you are there with your cell phone, there are very limited connection there. So our solution is basically we have our own camera, our devices, and the video and images collected by our camera will be just compute within the device itself, and the critical information such as traffic conditions, roadway conditions, and also some of the hazard events information will be transferred to communicated to a mobile app, and also the variable message signs in real time. Yeah. So another reason why they want us to do the data collection for things like semi trucks, agricultural vehicles, or even the presence of pedestrians at those locations is because they need those kind of data collection as evidence for some of the funding requests for from the DOTs or even the US DOT. Because a lot of grants application require you to provide evidence, especially database evidence, to be able to qualify for those kind of grants or even funding. But that's actually very not fair for a lot of the rural communities because unlike the urban area, the cities, they have a lot of sensors, so they can easily provide those kind of data to back up their proposal. But for those rural communities, they don't have such equipment. They actually have to rely on manual counting people to go into the field for those kind of data collection. So because of that, they are actually not qualified for a lot of grants application, even though they are the ones that actually desperately needed for those kind of funding. So that's why we're working with Juliana. She's very passionate, and she have worked with us for almost like 3 years. And through our data collection support, she's able to receive a lot of funding for AIWaysion. And actually, in the past few years, their conditions there improved quite a lot, especially with some of the funding from US DOT. Install at least 2 roundabouts that actually significantly reduces the serious injuries and fatalities.
That's great.
So another function I'm going to showcase is of some of the functions like detection of different kinds of objects, different kinds of road users like pedestrian and vehicles of different types. Into the tracking is important for pedestrian counting because unlike the standard view, vehicle pedestrians can loop in circles or go backward. So tracking can actually make sure that you don't double count the same pedestrian times. That actually make it for pedestrian counting. So we're doing the tracking constantly for all those road users. I'm also seeing some lagging on
Yeah,
my side. Is this?
I see a little bit of lag too. Your voice is cutting in and out.
Yeah, is this working? Okay.
Oh, it should be fine. I think it'll fix itself.
Okay. Yeah.
Yeah.
Move to the next slides. Yeah. So this is a project actually we for intersection safety. We as I mentioned last year we received this award from US DOT. They have this program called Small Business Innovation Research Award, SBIR. We received this award. That's why just when I decided to left UW because I need to be the PI for this project. We work with City Bellevue, Daniel Lai and Ride on this particular project, and also Verizon using their 5G communication capabilities. So we actually developed a system as you can see on the right side. You don't have to see all those details, but I can. So basically, the entire system is to support AI applications related to traffic intersection safety, like the detection of vehicles, their speed, and also their trajectory information for some safety-related applications. But the most importantly, it needs to happen in real time. So the approach we're applying for this project, basically we are using City Bellevue's existing traffic cameras, their live video feeds. We apply our algorithms on the edge and using Verizon's 5G communication to reduce some of the latencies for communication and also communicate with the traffic signal controller in real time with some of the extracted information like hazard events or some of the safety events. And then the traffic signal controller can basically implement some of the countermeasures in real time to improve traffic safety. We also have a dashboard developed. So for the traffic engineers or signal engineers, they can easily see the detection results in real time, and also implement the countermeasures. Yeah. So this is our algorithms. Most for a lot of our applications, we are using the same framework for so basically there will be a detection of the road users and also the localization, as well as tracking, as I mentioned. And with tracking, we can provide the trajectory of each different types of road users, and then we apply a prediction algorithm for using the historical trajectory information. And generates a predicted trajectory information, and based on that, we can have some more complicated safety applications.
Okay.
So this is normally how we track the vehicle. We basically object tracking is to determine if the vehicles detecting different frames in the video are the same vehicle. So based on that, we can generate the trajectory of the vehicle for each one of the road users.
Okay.
And then we use the LSTM neural network to train our algorithms to use the historical points and to predict the trajectory of the road users in real time normally for the next 1 or 2 seconds. So this dilemma zone event application is actually one application requested by this particular project. So this is a term in transportation engineering. Basically, it means if a vehicle is tracked in a dilemma zone, normally it's meaning the upstream intersection when the signal is turning from green to yellow. The vehicles that are trapped in this dilemma zone, normally meaning that it cannot safely stop before the stop bar or pass by the intersection during this yellow phase. So it's called a dilemma. So basically, yeah. So that's the very dangerous condition. So some people will just risk it and end up running the red light or just stop awkwardly in the middle of the intersection. Yeah. So yeah, so you can think imagine this is very critical information that the agencies would like us to collect and also be able to communicate with a traffic signal controller to hopefully reduce crashes related to those kind of dilemma zone conditions. So normally, if you are able to detect the dilemma zone events in real time, you can just tell the traffic signal controller to extend the green time for this vehicle for maybe 1 or 2 seconds so that it can actually safely travel through the intersection.
Oh, okay.
So that's one application we are doing. So this is actually a live video feed from City Bellevue. We're applying the algorithms for the detection of the vehicles and also the speed estimation of each vehicle. So when the signal had a turning from green to yellow, on this particular area, we're doing the speed detection and estimate the time it takes this vehicle to the stop bar before the red phase.
Okay.
And then another function for core function for this particular intersection safety project, we are doing the trajectory conflict event detection. Meaning is basically is a conflict events, meaning there are collision or near miss events, meaning this vehicles and a pedestrian, they are very close to each other. There could be a collision, but basically it actually somehow avoided it, but it's still very dangerous. So we're recording those kind of conflict events for further analysis. So I wouldn't go into detail for the prediction algorithm, but basically for each class of road users, like a pedestrian or different types of vehicles, or even a cyclist, they have different characteristics. Some of the, for example, pedestrians, they normally have a lower speed than a cyclist, and then cyclists have lower speeds than vehicles. So the prediction algorithm for each class are different.
Okay.
And with the prediction algorithm, we are actually able to train our algorithm have a very high accuracy, and then we can apply in real time for with the video feed from City Bellevue. You can see on the left side is showing in real time the green is a predicted trajectory in the next 1 or 2 seconds. And with that information, we can actually see for this particular project where we want to log events, conflict events, meaning the two objects within 2 seconds, there will be potential conflict points. So meaning their trajectory, predicted trajectory will be interacting in 2 seconds. So we will be logging those kind of events.
Okay.
So this is actually a video showing how we are doing this on the edge side. So this actually showcases how fast we can apply those kind of algorithms and it's not just only one function. We are basically doing this different kind multi-functions, multitasking at the same time on the edge side, at the same intersection with different kind of cameras. So you can see on the left side and the right side, it's a different camera views of the same intersection. So on the left side is actually more on the intersection area. We're focusing on the conflict events among different kind of road users on this intersection area. And then on the right side, we're doing the dilemma zone event detection. So you can see on the left side, there is a vehicle trying to turn left. And there's actually, based on the prediction algorithm for the trajectories, there is a potential conflicting points for these two vehicles. And actually on the so on the bottom is actually showing the how fast it's doing the tracking and detection and also prediction algorithm is all under 100 milliseconds. Yeah, I think that's all for the slides.
Wow.
So,
Okay. Thank you. That was a
Yeah,
lot
yeah.
of information.
Cool.
We do have a few questions here. So I guess I'll just put them up. The first one is, can you elaborate on how the sensor can decipher what the road surface conditions are, like wet versus icy?
Yeah, that's actually a good question. So maybe let me move back to the slides.
Okay. It's the beginning, I think.
Yeah. Let's see. So I'm not sure if this question is about road surface conditions in general or wet versus icy, because actually wet versus icy is one particular condition that's very hard to detect. So for some other condition like snow, ice is actually dry. It's easy to we have a higher accuracy. So wet and icy normally they are actually very close to each other, even with your own eyes.
Yeah.
So that's the reason why we just purely based on image processing, the accuracy is not very high. So we are able to actually improve the accuracy by adding another source of information. Basically, that's the environmental condition information. So as I mentioned, we have the temperature and humidity sensors attached into our system. So some of the conditions that are maybe very confusing for your eyes, we're able to detect, basically tell the difference between the icy and wet condition just purely based on the temperature. So those are some of the things we are taking into consideration. We were writing the machine learning algorithms.
All right, thank you. There's another one. How do you pick which places to put the must sensor?
Yeah, that's normally if we're doing this ourselves using the writing a proposal, we are looking through some of the crash data that are actually are public for everyone to see. Normally, WashDOT have those kind of data, DOTs have those kind of data, and also the cities they have those kind of crash history. So we are able to see which are the high risk locations that normally have a high frequency of crash rates, and we also normally we would work with the DOTs actually to ask for their opinions. They are normally very familiar with the roads where they want to install the devices.
All right, thank you. That sounds good. Are there any future goals you have for the must sensor? Any additional functions that you want to add to it, for example? Or
yeah, that's quite a lot. So
okay.
yeah, since we just started, most of the functions we're demonstrating here are based on some of the results we generated during our research. We carry on this in the company. As I mentioned, we received this award from US DOT. This is actually some of the new functions about intersection safety. But in addition to those roadway and also intersection safety, we will definitely work on those. But we actually have this vision to make this a connected vehicle device. So I know I didn't mention too much in this presentation about connected vehicles because I don't want to confuse people. But still, like connected vehicle, I think is a future for transportation, and also considering how you communicate information from the infrastructure to vehicle to pedestrian. We want MUS device to play a huge role in the connected vehicle, especially from the infrastructure side, to be able to use as a detection and also compute, as well as communication and control units, and to improve traffic safety.
All right. Interesting. This is the last question.
Cool.
Does the darkness/night affect how well the MUS sensor works and how accurate it is?
Yeah, it definitely affects. So in a perfect condition, like basically you have enough lighting, and also without no adverse weather conditions. And compared to those conditions, if you have weather conditions and also the low light condition, it definitely affect how accurate you can detect some of the objects. But still, like for MUS devices, our camera have the night vision functions, and also as I mentioned, we have this pre-processing algorithms to basically apply to images before we use our detection algorithms. So actually, it's easier for it would make this same detection algorithm much accurate applying to our pre-processing algorithms. So we have so basically we have a research project before, mostly just focusing on how to accurately detect objects under adverse weather conditions or low lighting conditions. Yeah. So basically, it's pretty accurate.
That's good. All right. Well, that should be it. Do you have anything else to add, Doctor? Or
yeah,
like
I think if you guys are interested, definitely just shoot me an email. Yeah.
Okay. Yeah, I will definitely provide your contact, like your email contact information. But thank you so much for this talk. Thank you everyone for joining. This was really educational, and I loved hearing about what the MUS sensor can do. So I think that's it for today. Thank you for coming, everyone, and we're so grateful for you, Dr.
Thank you.
Wei.
Have a good weekend.
Yeah. Thank you. Have a good weekend.
Thank you.
Bye.
Okay.